Today we analyze the images like this. We had images with different noise level, different thickness, and we found an automatic way that would generate measurement on every image, on every fiber, and create statistics. Let's go step by step to explain how it's done. Welcome to Analytical Antics. My name is Yuri and I answer questions about image analysis and solve imaging challenges. It looks like I just got an email. Alright, let's see here. Sup Yuri, your favorite marketing team here. We received a customer email with an interesting imaging challenge and we are pretty sure we know what to tell them, but we thought we should check with you first. Check it out. Okay. Here is a question from the customer. Hi MediaSci, I'm using an SEM microscope to capture micro-spun fibers at 500K resolution. The fibers you are looking at are part of a new product that we are developing, and the microstructure is very important. The project I've been assigned requires me to measure the average fiber thickness of all fibers in this image. I'm going to end up having hundreds of images that look like this, and I am struggling to find an efficient yet accurate way of getting this measurement and easy making a report for my manager. I'd really appreciate your help. Sincerely. Alright, let's see what marketing said. GTI marketing team here again, and this is obviously referring to fiber, right? Everybody should have enough fiber in their diet. I would know. Anyway, the customer mentioned average fiber thickness, and talking with the team, we think broccoli
Eat your broccoli
is probably the food with the highest fiber. I Google it and broccoli stem is about 1 inch thick. Hope that helps. You're the man. Crazy marketing team. Okay, let's show how to do it the right way. So what we see, typical micro-spun fibers on electron microscope. There are different type of fibers. We see different thickness of fibers, and they are crossed and in multiple layers. There is dark and bright fibers and noisy images. So how do we do that?
What do you do? What do you do?
How do we measure the fiber thickness? Typical way would be to measure it manually. So if we just activate manual measurements tool, we can create measurements of fibers and do it on the image, just adding measurements one by one. But it's the least effective way and prone to the customer mistakes, because it's very hard to click exactly on the edge of the image. So there is a little bit better way if we will use snap measurements. So we can just throw a line across the fiber and the measurement will snap to the fiber automatically. Still, we have to create hundreds of measurements manually doing 2 clicks. We can even make it faster using the single click. So for example, we can just use this measurement to click somewhere in the fiber and we generate measurement with a single click. Still hundreds of clicks, and talk about hundreds of measurements, we'll never do it in time. So what would be the right approach? I think the right approach would be to try to make a binary image and then measure thickness on binarized image. How do we create a binary image from this picture? We can use smart segmentation. So in smart segmentation, we just need to mark some areas which belong to fibers and draw some areas that represent background. When we do that, smart segmentation creates a preview mask, which we can just make it a binary mask, and that binary mask will represent fibers on multiple images. Of course, there is some noise and other problems, but this is a starting point and we can continue afterwards. Now let's talk about how to measure fiber thickness on binary images. I can draw a sample image, or I can just open existing one, and we'll explain how we would measure thickness on this binary image. You can see that there's some fibers. These white lines are fibers. Some fibers would cross each other, they have different thickness. The way we measure this image would be to apply distance map. So when we apply distance map to this image, it will create a new image where intensity of every pixel corresponds to the distance from the pixel to the nearest boundary. So the area, the intensity in the middle of the fiber represents the highest distance to any boundary. So this would be our thickness. So yeah, half thickness. So distance to here and to here, we double, we get thickness. We also need to detect this middle line where the thickness will be measured. The middle line can be measured using the skeleton operation, thinning. We apply thinning, we get middle line, we have distance map, we measure intensities. So then we just go through this skeleton line with certain interval and measure intensities at every pixel. We exclude crossing point, so crossing point typically would be the areas where we don't want to measure thickness. We want to exclude them. Before, we could just write a macro that would do all these operations. It could be quite complex macro going through all the steps and generating data. But luckily, now we have protocols which we can use to measure fiber thickness. And the protocols, one of the pre-installed protocols called fiber thickness. So we just find it in the list, load proper protocol, and pick the image we want to analyze and go through the steps. Interactively, we can adjust multiple parameters, but when we are happy, we can say OK, and program will generate measurements for fiber thickness on every fiber. You can change distance between steps, step distance. This is the distance between the measurement line. We can make more measurements, less measurement. We can even create just one measurement per segment of the fiber. And when we go to the next step, we generated the data, and the data will be reported in the data table where we have number of measurements, average thickness, minimum, maximum, standard deviation. And that's all for a single image. Customer asked us, is it possible to process hundreds of images in automatic way? Let me show you how to do that. In protocol handling, we have a run batch functionality where you just pick a folder with your sample images, click process selection, and the protocol runs through all images in parallel threads, doing it very quickly and efficiently, and then we generate data for all measurements. And now we have we can get statistics, we can get analysis of every image, and if you want to make a report, we just pick whatever report we want to use. In my case, I want to use fiber thickness multiple sites. We click open and click generate report. And this is a report of multiple images where we have average thickness per image. Then we have angle. We have statistics, including minimum, maximum deviation. And we have screenshots of every image on the in the batch. And that's how it's done. All right, let's get the solution off to the marketing team so the customer can get started.
2 hours later.
I'm back. I just typed a message to marketing team letting them know that I think this would be a really good solution for the customer. It would allow them to analyze their images accurately and efficiently on their hundreds of images and send a report off to their manager. Oh, looks like marketing team already responded. They said, great, thanks Yuri, be sure to mention broccoli. So yeah, okay, sure, I'll do that. Do you have an image you'd like us to analyze in Analytical Antics? Send your image and solution in the comments below and we'll look at it. Thank you for your attention. See you.